Hey, Dr. Clark coming at you with another financial mathematics video. This time we're looking at buying and selling bonds. We're going to start with a little bit of review from section 4.1 and then we'll move into section 4.2 in the next video. So the first thing we want to do is first look at that bond pricing formula. So that bond pricing formula from section 1 takes into account a couple things. First, we're looking at the present value of the bond. So what I mean by that is in a time diagram, this is time zero, this is now. In the future, you're going to pick up some coupons, right? Every year or every 6 months, they send you a coupon. And this portion of the formula prices those coupons. Now think about what that coupon is. It's a payment, say $100 every year for the next 10 years. Well, that's 10 payments, and we're going to present value them all back using the time value of money formula. And so we want the value now of those future payments. Well, this is the formula that tells you how to do it. FR, F times R is the face value of the bond times the coupon rate. So that is the size of the coupon. That's the coupon size, $100, $20, whatever it is. And then that A and J, that's the annuity formula, right? And that's because an annuity is a continuous series of payments that are coming in the future. And you can think of coupons as a continuous payments that come in the future, and it present values all of them back to the now. Then, at time n, whenever that is, you're going to get another big lump sum payment, and we want that present valued back as well. C is the size of the payment, that redemption value, right? So J is our interest rate, N is the number of periods, F is the face value, R is the coupon rate. That's that FR right there that calculates the coupon size. And then C is that redemption value. And what we're going to do is when we divide C by 1 plus J to the N, that gives us the present value of C dollars, not now. C dollars is worth now C dollars. But C dollars 10 years from now ain't worth C dollars now. So we present value that back to the now, right? And that's that portion right there in red. Okay, so the bond pricing formula takes into account the redemption value, present valued back, and the coupon payments as an annuity. All right, so let's use that formula to do some problems and kind of get some review in. So the first question, as the concept question, is what is a zero coupon bond? And of course, a zero coupon bond is a bond with no coupons. Okay, in other words, R is set equal to 0. The coupon rate is equal to 0. If you're going to price it, it's just C over 1 plus J to the N. Okay, because there's no coupons, right? Plus 0 coupons. So a zero coupon bond just has a single payment, 10 years in the future, 5 years in the future, whatever it is. All right, next question. As the coupon rate increases, the price of the bond increases. Okay, why does that happen? Well, F times R is the face value of the bond times the coupon rate. That equals the coupon size. Okay, and as you get more coupons, they're going to cost more money, right? You got to pay the money now to get the coupons in the future. Well, if you want bigger coupons, you got to pay more now. As the yield rate increases, the price of the bond decreases. Now, this one is a little bit tricky, but let's think about that in a couple different ways. Let's say you invest $2,000 now at, 20% interest. Well, 3 years from now, you might have a lot more money. In fact, we can just calculate that out. What's 2,000 times 1.2? 20% interest to the third power. That's $3,400, right? So, a small amount of money now can turn into a big amount of money later if the interest rate is high enough. Now, if the interest rate is smaller, a small amount of money now will stay small for a longer period of time. Well, what this question is doing is it's coming backwards. It's saying if you start with money in the future and you present value it back, what happens? Well, if the interest rate goes up, the present value goes down because the future value is fixed. So if this number gets bigger, that number has to get smaller. Hence, that price decreases. That's one way to think of it. Okay. Another way to think of it is to say something like, just look at the formula. Say C over 1 plus J to the N. Well, let's say the interest rate goes up. Well, you're dividing by a bigger number then, aren't you? Which is going to make the present value go down, right? So you can think of it that way. If the interest rate goes up, the interest rate's in the denominator. That's going to make the bond price go down. And then the last one. The present value of the bond coupons can be priced using what formula? It's the annuity formula, right? The coupons are basically just an annuity. All right, let's keep going. We've got a check your understanding problem. So what I recommend here is for you to pause the video, do the problem, and then I'll walk through it and give you the answer. So pause the video, work through it. If you're understanding everything from section 4.1, you should be able to do this problem. All right, so I'll give you a minute to do it, and then I'll go over the answer. All right, so we're back. I put the bond pricing formula down there in the corner. This question is saying, what's the market price for a 10-year bond with the following conditions? Semi-annual coupons with a coupon rate of 4% nominal. Now, semi-annual means you're getting them twice a year. If you're getting them twice a year, you don't get 4% twice a year. That's nominal. So you're getting 2% twice a year. The face value is 1,000, so the coupons, in this case, we can already figure that out, is just 10,000 times 0.02. 10,000 times 0.02 is $200, but you're getting those 2 times per year. So once every 6 months, once every semi-annual period, you get a $200 coupon. What else? The yield rate is 5% nominal with semi-annual compounding. That means the J is 0.025. It's 0.05 divided by 2. Semi-annual compounding means we're dividing it by 2 twice per year. You don't get 5% twice a year. You get 5% divided by 2 twice a year. So 2.5% is your J, and your C is equal to 12,000. N in this case is going to be 10 because it's a 5-year bond with semi-annual compounding. That's 5 times 2 is 10. Okay? And now we can basically just say the present value of the bond is going to be 12,000 divided by 1 plus J, which is 1.025, to the N, which is 10, plus the FR. Well, we already calculated FR to be 200, and then we just need that annuity formula, which is 1 minus 1 over 1.025 to the 10, divided by 0.025. And if we run that into a calculator, we can get the value. So 12,000 divided by 1.025 to the 10 plus 200 times that annuity formula right there, 1 minus 1 divided by 1.025 to the 10, all divided by 0.025. And I'm getting, as my final answer, $11,124.79. Okay, so if you did it correctly, hopefully you get that. And what you should notice is that, even though you're getting $12,000 in the future, the present value is less because you're paying less now to get $12,000 in the future, right? That's how interest kind of works. All right, so that's the end of this video. If everything is making sense there, hopefully you're able to do sort of the basic bond problems. And in the next video, we'll kind of learn a few new items. So we'll see you in the next video.